Hello everyone. So we are going to start the next topic, calculus, in which we are going to see many different subtopics like we'll check limits, continuity, differentiability, partial derivatives, maxima, minima, and intermediate forms, evaluation of definite and indefinite integrals, then double integral, multiple integral, partial derivatives, total derivatives, Taylor series, Fourier series, and then we'll also get into vector calculus where we'll see gradient, divergence, curl, vector identities, directional derivatives, and for some of the branches we'll also be looking into vectors in plane, space, and other vector operations and identities. Other than that, in the vector calculus we'll see the line integral, surface integral, volume integrals, and related to that we'll see the theorems like Gauss theorems, Stokes theorems, Green's theorem. We'll also see the application of integration. Right? So we are into the new unit, calculus, and here we are starting with the first topic, limits. So let's say we have a function f of x which is defined in certain interval which contains x is equal to x naught, and this function f of x may or may not be defined at x equal to x naught, then the limit x tends to x naught for f of x is equal to L, that is the limit if the mod of f of x minus L is less than a certain positive value epsilon for x minus a or x minus x naught is less than del naught, where epsilon and del naught are positive. You can consider it to be small values, right? And also for this we need that the function has the right hand limit and left hand limit to be same and equal to L. So this is in something in words. We'll understand what is it, and we'll also see the left hand and right hand limits. This is left hand limit and this is right hand limit. So it says if a function is defined in certain interval which contains a value x is equal to x naught, let's say this x naught is equal to 2, then this function is defined in the region such that that region contains 2. So let's say if we are talking about a region from 0 to 4 and x naught is equal to 2, so this 2 lies in that region 0 to 4. Now whereas function may or may not be defined in that x equal to x naught. So it is not necessary that the function should be defined at x is equal to x naught. Then the limit is given as x tends to x naught of f of x equal to L if the mod value, this is the mod value of the distance or the difference between the function value and a certain constant L, which has to be less than a finite value, which is a positive finite value epsilon, for all the x which is approaching x minus x naught being del naught. This means, in short, this means when x is approaching x naught, that means the absolute difference between them is very small, the function should be approaching a constant L. And for this it is necessary that the right hand limit and the left hand limits are same and is equal to that value L. So we can also understand this in terms of graph. Let's say we have this certain function, let's say this is f of x, and at some point this is having a break. So there are chances, and this is nothing but x naught, this is x. Fine. There are chances, it's not necessary, but there are chances that the function may not be defined at, you can see a small break here, so may not be defined at that point x is equal to x naught, and this value is nothing but L. So the understanding is, when your x, the variable, is approaching x naught, that is, it may be approaching from the left hand or it may be approaching from the right hand. So when your variable is approaching x naught, this is x naught, so when you are approaching from the left hand or you are approaching for the right hand, then the function value is also approaching a certain value which is L, right, which is L. So this absolute difference from L, the function's value, absolute difference from the function from this value L, or the variable's absolute difference from this x naught, starts reducing, starts getting very, very small. So in that case we say that this function is limiting to L when x tends to x naught, and this approach of x to x naught from lower side, that is the value less than x naught, is the left hand limit, and when you are approaching it from the right side or values greater than x naught, then we say x tends to x naught right hand limit, and they represent minus here, x naught minus or x naught plus. That means you are approaching from the values less than x naught. So finally you are approaching this value x naught and the function value is approaching this constant L. So in that case you can say that the function limit exists. So then we say that function limit exists and it is equal to L. We have to mind this, that there are possibility that sometimes you will see that function value is limiting to or tending towards infinity. So we should understand that this infinity is not a real number, right? It is an expression that it is going very far, whether it is going to a positive infinity value or minus infinity value. So you cannot equate two different limits when you say that both are limiting, when both are tending towards infinity. You cannot compare or you cannot equate them. right? We say that because it is tending towards very high or very low value. So in that sense we say that it is tending to infinity. The limit is infinity, right? Other than that, we can check some of the properties. The properties are, let's see, if, let's say, if limit x tends to x naught for function f of x is L, like we said, and limit x tends to x naught for a function gx is M, then limit x tends to x naught for f of x plus g of x can be splitted and said as limit x tends to x naught for f of x plus limit x tends to x naught. So we can split this and we can write it to be L plus M. Similarly, if there's a difference, so in short I'm writing it whether it is plus or minus, it is same. Whether it is plus or minus, it is same, right? No need to write it again. And there are possibility that it is in the form of product. So limit x tends to x naught x tends to x naught for f of x g of x is given by limit f of x for x tends to x naught into limit g of x for x tends to x naught, and it can be given as L into M. Also, if it is in the form of division, that then also it is valid. X tends to x naught f of x by g of x is given as limit x tends to x naught for f of x divided by limit x tends to x naught for g of x, and this can be given as L by M. The condition is M should not be equal to 0, right? So there are some special limits also, or special conclusion or results, that also we can see. It is like some results. We are not getting into the derivation or like how we are getting these results. Like, let's say limit theta tends to 0 for sine theta by theta is equal to 1. Also limit theta tends to 0 1 minus cos x, or I'll say theta, by theta is 0. Also limit tan theta by theta for theta tends to 0 is also 1. Apart from this, limit x tends to infinity for 1 plus 1 by x to the power of x is given as e, and limit x tends to 0 for 1 plus x 1 by x is also e. There can be small modification, and if we write limit 1 plus let's say a by x to the power of x, where x tends to infinity, then this can be given as e to the power a, and limit 1 plus a times of x 1 by x, where x tends to 0, is given by e to the power of a. So these are some of the results we'll be using. Apart from this, we can also see the very important rule, which is L Hospital's rule. In this, let's say if there is a function f of x and g of x, then the limit x tends to x naught of f of x by g of x, if taking a form 0 by 0 or infinity by infinity, which is known as, that is, indeterminate form, then the limit of x tends to x naught f of x by g of x is given as limit of x tends to x naught f dash of x by g dash of x, right? And in case, you can add here, that is, in case f dash, I'm simply writing f dash, and g dash also behave in same or similar manner, then we can repeat this process. Also, other indeterminate form are, this is 1 to the power of infinity, 0 to the power of 0, infinity to the power of 0, 0 into infinity, infinity minus infinity. So these are the 5, and this is 1 and 2. Overall, you may need, in case, then there are 7 such forms of indeterminate form we may come across. So this L'Hospital cell says, if f of x and g of x are there, and we are trying to find the limit of f of x by g of x for x tends to x naught, and if it takes any of this form of 0 by 0 or infinity by infinity, which is known as indeterminate form, then for finding the limit, what we can do is, instead of limiting f of x by g of x, we can limit the f dash of x by g dash of x for x tends to x naught. So this will give you the result. And in case it is still taking the same form of 0 by 0 or infinity by infinity, then we can repeat the same process. That is, we can again differentiate the numerator and we can again differentiate the denominator, and then we can try to put the limit x tends to x naught. Other than that, there is one small expression which you can a theorem which may other than that, we may come across one more theorem in applications, that is squeeze theorem. You may find it as sandwich theorem also. So let's say if there are certain functions, let's say f, g and h defined in certain region, defined in the region, let's say R, with the condition that this f of x, g of x, h of x satisfies this condition for all the values of x in this region R. Then if I'll say if f of x for x tends to x naught is equal to L and h of x for x tends to x naught is L, then g of x for x tends to x naught will be equal to L, right? The point is, if this function f of x, g of x and h of x are satisfying this condition such that this g of x lies between f of x and g of x in the region R, and then the condition that x naught is within this region R, of course the region we are talking about, if the function limit is L for f of x and h of x, then the g of x should also have the same limit L, right? It will have the same limit. Also, if it is having, like, let's say this is having a limit of a, this is having a limit of b, then the limit of g of x should lie between a and b, because for all the condition g of x is lying between f and h, right? So these are some of the properties and theorems which we may come across in questions of limits.